This is a short video on the subject Digital Electronics, code 3CS304 for BTech Computer Science students, third semester. We'll begin with an introduction to a digital circuit. Let's have a bulb and a switch connected with wires to a battery. When the switch is off, it is in off position at present, not connected. The bulb will not receive any current due to open circuit and the bulb will be off. When the switch is closed, then the bulb will receive current, and due to this connection the bulb will be on. So when the switch is on, bulb is on. When the switch is off, bulb is off. Now this table can be written like this also, using digits, numbers. So this electronics is now digitized using numbers. So that's why this representation, you can say, it is an way of having electronics represented with digits. So digital electronics, digits represent symbols, numbers. Electronics is electron mechanics, how electrons move through the wire. So this representation is same as this one, so it conveys this information. Switch is off, 0. Bulb is off, 0. So 0 as an input gives 0 as an output. 1 means on as an input gives 1 as an output. So bulb will glow when the switch is on. Now let us have another circuit example. In this, two switches are there. When both the switches are off, the bulb will not light up because there will be no current flow. In next combination of switching action, we keep one switch off, another switch on, gives us the bulb in off condition. Then we put the switch 1 on, switch 2 off, again it will be off. When both the switches are on, then only, this is wrong, let me update this table. So we have found a correction, that is, when both switches are on, then we have identified that the current will pass through. That on means connecting these two. Okay, you just connect this wire, that means this is on, this is on, and when this is on, the output will be on. And when one of them is off, then output will not be generated, the bulb will be off. So I have corrected this table, and this is the correct table, and it is AND logic. Why is it AND logic? Logically what happens is, when switch 1 and switch 2 are on, then the output is on, output is 1, output is received, the bulb is on. Another circuit example, when there are two switches connected in parallel, this is series connection and this is parallel connection of switch. When both the switches are off, current will have no path to reach the bulb. When one of the switches is on, the current will have a path, a single path will be there to complete the loop, and so the bulb will be on. Similarly, if other switch is on, another one, the second one is off, still the current will be able to reach, so the bulb will be on. Then both of them, if we connect them, obviously the current will go through both, or however way it divides. It is a concern of electrical circuits which has got lower resistance path, so that will allow current flow. But both are, ideally we think that when connecting these, it gives a short circuit, so current will go through both the wires and reach back to the battery. In that process, it will light up the bulb. So both are on, this will be on. So this is OR logic, either switch 1 or switch 2. Did you hear? Either switch 1 or switch 2 is on, the bulb will be on. So either 2 or 1 is on, the bulb will be on, or both are on. So that's why this is called OR logic. So by now you must have learned that we have digits being used to represent electronics, so we need to study number systems, and that's where our unit 1 begins. So in number systems we have been dealing with decimal number systems in our daily lives. So that is base 10 system. Why base 10? Because basically there are 10 different drawing symbols used to represent numbers. So these are our numbers, 10 numbers. Count them. These are 1 to 9, 9 numbers, and one more number, this 0, adds them up to total 10. How do we count in this number system? Everybody knows by now. You are quite familiar with this due to our this use of these numbers in our daily lives, in counting money, in counting dates, in counting days, weeks, so many things we use base 10 system. So we'll use other systems also, just as we use kilogram, gram for different quantities. In different places we use different number systems. Later on that, first let's start counting. We know 0 1 2 3 4 5 6 7 8 9 10 11 12 is some basic counting, but we have to identify a basic thing in this. The basic construct in this is that when we count on these, we have units place that counts up to 9, then we have to increase one more position. That position is called tens place, and then we can count further. And notice that we don't change the drawing, we don't have any other new introduction, we just combine the numbers, we code the numbers in such a way, in such a pattern, so that we can construct different picture from the picture that we have already drawn. So you can count up using these only using these 10 different drawings, and count to as many numbers as you want. You can construct from these, count up. So let us discuss another number system, base 10 it is. Base 10 means there are basically only two drawings, 0 and 1, and these are called bits. We use them to represent off and on condition, and the bit expands to binary digit. Okay, so the short form of binary digit is bits. Let's count in binary number system. If we have just one bit, we can count up to 0 1. That means we can count up to 2 steps only. But if we have two positions, then we can count up to four different numbers we can write. So this will represent 0, this will represent 1, this can represent 2, this can represent 3. How we build these numbers, that we can again relate back to the basic construct, that we first write 0 and 1. When we run out of our numbers, then we increase one more place, and then arrange the numbers in such a way that we can count up. Again we run out of all combinations using two numbers or two places, then we increase one more position and then count up. Okay, so this is the way we can increase the places and count to higher numbers. We can compare these countings. We can count in decimal like this. We increase the place to two places, ones place, tens place, we can count up to 99. We increase further, we can count up to 1000 numbers, including the 000 and 999 becomes 1000. So we have units place, 100 place, and thousands place, and so on. Similarly, both systems are designed having the place in base 10 system. The places are units place, tens place, 100 place, thousands place, and so on. So these are called decimal weights. These are weights. We can choose these weights with the numbers in the given set and formulate or construct a number. Similarly, in base 2 system, which is binary number system, we can have weights and we can construct numbers. So this is just an introduction. Let us use this, how to construct, how are numbers constructed using these weights. So for an example, we will need to construct 13, which is in base 10. We can write this, rather than writing this line, we can straight away write this, and this means that we are trying to write the number 13 with base 10. How would we do that? We have this table with us. So there is this table, the weights. We choose these weights with the numbers. So we need, how many tens do we need to create 13? We need 1, tens, and we need 3 ones. So we get 1 tens plus 3 ones, which gives us 13. So this is how weights are used to construct decimal numbers. In similar way, we can construct binary number also. So what will be the binary equivalent of 13 in decimal? So this is base 2, which represents binary number. This is a question mark. We need to find out. What we do is we write the weights of binary number. These are the weights. 2 2 to power 0 gives us 1, 2 to power 1 gives us 2. So these are the places, and in these places we need to get 13 as a weight. So 8 we need one time, 4 we need one time. We cannot take more than one time because binary number has a set of only two different symbols, digits, which is 0 and 1. So we pick out 4 one time, and then we pick out 1 one times. See what happens. 1 8, 1 time we pick out 8 8, one time we pick out 4, then we don't need 2, we need 1, we get this, we add these up, we get 13. So this is the decimal number, and the binary number that we get, the equivalent we get is 1101, which is this. So this number 1101 in binary represents decimal number. So I have prepared this short introduction to our course, and in class we are discussing to length. So many things are being discussed. It takes time to make these videos in class. If somebody wants to make videos, they are welcome. Thank you, and hope to see you in our class at COMPUCOM College. Thank you.